Amplifiers. There does exist, however, a class of machines known as amplifiers, which are able to take in small power signals and output signals of much greater power. The key to understanding how amplifiers can exist without violating the law of conservation of energy lies in the behavior of active devices. Because active devices have the ability to control a large amount of electrical power with a small amount of electrical power, they may be arranged in circuit so as to duplicate the form of the input signal power from a larger amount of power supplied by an external power source. The result is a device that appears to magically magnify the power of a small electrical signal, usually an AC voltage waveform, into an identically shaped waveform of larger magnitude. The law of conservation of energy is not violated because the additional power is supplied by an external source, usually a DC battery or equivalent. The amplifier neither creates nor destroys energy, but merely reshapes it into the waveform desired as shown in the figure below. While an amplifier can scale a small input signal to large output, its energy source is an external power supply. In other words, the current controlling behavior of active devices is employed to shape DC power from the external power source into the same waveform as the input signal, producing an output signal of like shape but different greater power magnitude. The transistor or another active device within an amplifier merely forms a larger copy of the input signal waveform out of the raw DC power provided by a battery or other power source. Limitations of amplifiers. Amplifiers, like all machines, are limited in efficiency to a maximum of 100%. Usually, electronic amplifiers are far less efficient than that, dissipating considerable amounts of energy in the form of waste heat. Because the efficiency of an amplifier is always 100% or less, one can never be made to function as a perpetual motion device. The requirement of an external source of power is common to all types of amplifiers, electrical and non-electrical. A common example of a non-electrical amplification system would be power steering in an automobile, amplifying the power of the driver's arms in turning the steering wheel to move the front wheels of the car. The source of power necessary for the amplification comes from the engine. The active device controlling the driver's input signal is a hydraulic valve shuttling fluid power from a pump attached to the engine to a hydraulic piston assisting wheel motion.